Okay, this isn't in your book, but I want to briefly talk about precipitation and precipitates. So, and this actually was pretty relevant to your lab a couple weeks ago. So, imagine two solutions of soluble ionic compounds mixed together. So, let's take, for example, sodium chloride. Now, for this, it's going to be helpful for you to have that solubility chart sitting in front of you. So you might want to get your book out and look at the solubility chart on page 211. So, sodium chloride is soluble, right? If you look at the chart, sodium solutions containing compounds, ionic compounds containing sodium are always soluble, no exceptions. Silver nitrate, right? Silver nitrate is soluble because nitrate-containing compounds are always soluble. So what I have over here in one beaker is remember, so I've got sodium chloride here. Now remember, what happens to solutions or ionic compounds when they dissolve? Right? They dissociate. So I don't really have sodium chloride. What I have is a big beaker full of sodium ions and chloride ions, right? They're not really sodium chloride. That's just how it's written on the bottle. Now, over here I've got silver nitrate, right? And what I have, because it's soluble, I've got silver ions and nitrate ions. Now what I'm going to do is I'm going to mix these two together into another beaker. Now what I'm going to have is a big bunch of sodium ions, silver ions, chloride ions, and nitrate ions. Right? Okay, so here's what happens. Remember how I described solubility? Solubility, right? Solubility is, or ionic compounds are soluble if they're more attracted to the water than they are to each other. So what we need to do is we need to look at any new possible ionic compound combinations we can make. Because if any of them are insoluble, then they're going to want to hang out together instead of with the water. So we can't combine silver and sodium. That's not a compound. They're both cations. That doesn't make any sense. We already know that silver and chloride, or sodium and chloride, are aqueous. They dissolve. Silver and nitrate dissolve. We only have two more possible combinations. Silver, so swapping the anions, silver and chloride and sodium and nitrate. Now, sodium nitrate's easy. Sodium and nitrate are both always soluble all the time, so definitely they're soluble. So realistically, they're not really sodium nitrate. They're really more sodium and nitrate. Silver chloride, however, that's insoluble. If you look on the chart, chloride is an exception to the generally pretty good solubility of chloride compounds. So what happens is the silver and the chloride start bumping into each other, and they make this cloudy stuff, right? They make this sort of cloudy thing that forms, and if you let it, it'll actually settle out into a solid at the bottom. Now, we did this exact thing a couple of weeks ago when you were doing tests for ions. Now, I don't know who of you had chloride in your compounds, but, actually, no, I guess it was just last week, wasn't it? Anyway, but what we're really doing there in the ions lab is what we were doing then was we were testing to see if there's chloride in your compound, right, or in your solution. So if you add silver nitrate, what does that tell you, right? If a precipitate forms, that means that this precipitate must be silver chloride, right? And if it doesn't form, then there must not be any chloride in there, otherwise you would see that precipitate. Or at least not very much chloride. There might be a tiny, tiny, tiny bit. But that is where that comes from. So this term is a precipitate. The word precipitate means the substance formed from a solid substance that's being formed from two solutions mixed. So So that means that these reactions are called precipitation reactions. So in chemistry, we're specifically referring to solid forming from solutions. However, this is not completely removed from the term precipitation that you might be used to, right? In meteorology, we're talking about water that falls from the sky or solid or whatever. So we're talking about mixing two gases where you have vapor up in there and then they mix and then water comes out. So another phase comes out. So they're related terms. So in chemistry it's specifically referring to this solid coming out of solutions, but that's why there's the two terms. So, and there it is. And so I really just want you to be aware of this process. And if you were to go back and look at the lab we did last week, many of the tests, not all, some of the weird ones there were some weird ones in there, but many of the tests were just precipitation tests. So there you go.